So class, we're starting on example 3 from 6.3, and we have the equation r equals 4 cosine 3 theta. So in keeping order, in order to graph this, we're finding the maximum r values here first. Then we're finding the zeros. Then we find symmetry. And then we plot the points given all that we know from the above. All right, so let's just start out slow. We have a cosine 3 theta. So that has to be between -1 and 1, okay, because we know about cosine. So when I set absolute value of r, substitute in the equation with a -1, so it would be 4 times -1, I get the absolute value of -4. If I do the absolute value of r equals 4 times +1, I get the absolute value of 4. So that tells us that I will need to go, my graph will only be out to 4 on the rings. I don't know what angle it's for in -4 yet, but I'm going to find out now when I solve first for -4, and I get 4 cosine 3 theta. So cosine 3 theta is -1. So 3 theta is equal to pi. Now I have to keep going because 3 theta is 3 times as big as theta. So instead of going to 2 pi, I have to go to 3 times 2 pi, or 6 pi. So there I have pi, 3 pi, going around another time, and going around 2 pi more will give me 5 pi. So I had to go around the ring 3 different times to get those. But I have to divide by 3 now to get theta. So the pi becomes pi over 3. 3 pi becomes pi, you can see it right below it, and 5 pi becomes 5 pi over 3. Those were for the -4. That's where they equal -4. At pi over 3, pi over pi, and 5 pi over 3, we have a -4 radius, r. Now, r at 1, okay, +4, is cosine theta equals +1. And so 3 theta at equal, where does cosine equal +1? At 0, but then I have to go all the way up to 6 pi. Well, I use 0, so I go all the way up, and then I don't have to use the higher one because I use 0 instead of the 2 pi. So 2 pi, 4 pi. So then dividing by 3 would be 0, 2 pi over 3, 4 pi over 3. I don't go to 6 pi because that would be the same thing as doing the 0. So this is where it equals 4. So I can actually, if I'm making my chart and I'm doing all the points, I know that I have a point of 0, 4 from this. I know I have a point of 2 pi over 3, 4. So did I do 2 pi over 3? 2 pi over 3, 4. And I know I have a point 4 pi over 3, 4. But it looks like I didn't need to go that far because of symmetry. I know I have a point pi over 3, -4. And I know I have a point pi, -4. And then I didn't need the last one because of symmetry. So that's what that told me. Now I'm going to the zeros. I set the equation equal to 0. I get cosine 3 theta equals 0. Okay, I'm finding 3 theta first. Where is cosine equals 0? It equals 0 at pi over 2. Okay, and 3 pi over 2. But I have to keep going because it's 3 theta instead of theta, and I have to go all the way up to right before 6 pi. So that would be 5 pi over 2, 7 pi over 2, 9 pi over 2, and 11 pi over 2. 12 pi over 2 would get me 6 pi. So I go all the way up to 6 pi, not including. That was for 3 theta. To get actual theta, I have to divide by 0. I have to divide by 3. So 2 pi over 2 becomes pi over 6. 3 pi over 2 becomes pi over 2. 5 pi over 2 becomes 5 pi over 6. 7 pi over 2 becomes 7 pi over 6. 9 pi over 2 simplifies to 3 pi over 2. And 11 pi over 2 simplifies to 11 pi over 6, or goes to 11 pi over 6. So I also know that at all these points right here, I have 0. So I know at pi over 6 I have 0. I know at 5 pi over 6 See where 5 pi over 6, I have 0. And then it looks like the rest, oops, I missed pi over 2. Pi over 2, I have 0. And it looks like the rest worked because of symmetry. I didn't need to have those out. Okay, so I've got those points. Now, let's do symmetry. It's a cosine. First thing I see is it's going to be symmetric to the polar axis. When I put a negative 3 theta in there, it will just become the same thing. So I know that it's symmetric to this axis right here. I'm on the graph now with orange. So I only have to graph these points, and I can do all of them if I want to have a better graph. So these points, I only have to do these. So going around, I do those points, and that's what my plotted points are. Now to save time, in the calculator, I put y1 is equal to 4 cosine 3 theta, and then you can't go to the table and just do it that way because it doesn't go up by these numbers. So you have to you have to go to table set and change it to ask at the bottom there. You want to change it to ask, just the x, and it lets you put in pi over 12. All right, so that's how you would do it. You know, if you can't figure that out, you just have to punch it in individual. It's not a big deal. It just takes longer if you have to keep punching in 4 cosine 3 times pi over 12. But, I mean, that's what you do. You just put it into your calculator. So let's talk about the numbers I got. I got 2.8 at pi over 12, and at pi over 4, I got another 2.8. At 5 pi over 12, I got negative 2.8, and at 7 pi over 12, it started to repeat. Okay, so I am going to graph what I had so far. So at 0, 4, R is... Now remember, when we do theta, we pick theta, but the point is 4, 0, right? Just so you know. So it is right here, this orange dot, right there. Now, at pi over 12, it was 2.8, which would be this dot right here. If you can see me, the orange appearing on the graph. And then, because of symmetry, I can put this pi over 12 one, negative pi over 12 in also. And then it goes to, at pi over 6, it goes to 0, which means we have to have a pedal, because it went and came around to 0. All right, so now I go to pi over 4, and I get negative 2.8. This is pi over 4 right here. So negative going backwards would be way down here. This is negative 2.8. So that's that point right there. At pi over 3, I get negative 4. So here I am at positive pi over 3, but I have to go backwards. So I get this point right here on the graph. And then at 5 pi over 12, this is 5 pi over 12, I go backwards to negative 2.8 again. And then it goes to 0. Now what I didn't do was the symmetry across the axis. So because this is symmetric, I can do these points. This one matches this one, and then that one, and then that one. And I get another pedal and another pedal. Now what happens if I keep going? If I do 7 pi over 12, I'll repeat and get the same things. So you're done with the 3 pedal rows. So that was example 3.